Good morning, everyone. This is Munia Ahamed from Australian Cobotics Center. So, here we are to share our latest insight on harmonizing the mind and machine, which is strategies for symbolic knowledge exchange in collaborative robot. So, this presentation outlines our journey, findings, and aspirations in exchanging human robot collaboration with a keen focus on the symbolic exchange of knowledge. We have done some literature analysis, and we are in the mid of this project, which we will be going through throughout the presentation. How actually the journey have started? We might think like the human robot collaboration may be a very new kind of thing. Like we are just started human robot collaborative workplace, human robot collaboration, but it's not actually a new thing. But it has been evolved over the period of time. So, when we have started our exploration into the evolving relationship between the human and robot, charting the journey from the coexistence to active collaboration. Basically, initially, when human and robots are like distinct neighbors, sharing the same space but not interacting meaningfully, like human was working with robot, but they are not exchanging anything with each other. But over the period of time, as humans become more comfortable with the presence of robots and technological advancement, this relationship has transformed, which have made them as a neighbor starting to communicate and find a way to assist human perspective and technological advancement. So from human side, it's all about growing from accounts to robot, learning to trust them and discovering the most effective ways to work together. And technological side, it involves designing the robots that can interpret the human cues like gestures, the voice recommendation, then making them more capable collaboratives. Then essentially this slide basically narrates the story of how human and robot, that whole transition from the simplest sharing an environment to working in a normal environment, and then enhancing the productivity of the working place, and then how they enhance the efficiency, vice versa, much like neighboring, the moving beyond the casual greetings to jointly creating a community garden, and symbolizing a deepened partnership and shared goals to develop the manufacturing industry as a better platform. So if you look at the image, you can see now we are in the level 5, where we are not only working on the human robot collaboration, we are also working for the safer workplace. We are also designing the workplace safety. So now we are just not about the collaboration. We are also working or focusing more towards the whole concept of the collaborative workplace. So, how the knowledge transfer between human and robot? Because human and robot, yes, they can work together, but if human and robot is just working with the based on the system or software, but they are not sharing their knowledge with each other, meaning over the period of time, either human will be replaced by robot, or robot will be there will be no use of cobot like collaborative robot. Either people will go for only the industrial heavy robot, or they will go for human. So there must need to be a potential knowledge transfer where human expertise can be used, and also the uh, robots expertise like robot skill can be used, and together they both can work as a colleague and share the both expertise. So in this image, we have tried to collaborate the human robot expertise, and then we try to connect with the knowledge transfer. So at the heart of our inquiry, we have started to dance of the knowledge exchange, like how human and robot can really transfer their knowledge. So on that representation breakdown of the processing of the encoding, sharing, decoding the knowledge access between the human and robot agents. So this model actually underpin the theories of knowledge management and communication, and then examine how the context, then interpretability and adaptability influence the efficiency of this exchange, because it's not just only exchange. Once you exchange the knowledge between the human and robot, how that's making the environment more efficient, and vice versa, how that is making the more the whole productivity, like how that is actually making your manufacturing more productive. And then a special emphasis is placed on the role of machine learning, natural language processing in transcending the traditional barriers, facilitating a dynamic two-way learning process, meaning here not only human will be learning from a robot. It's not like only human will be learning how robot can work faster, or how robot can help them. Vice versa, robot or collaborative robot also can learn from human, can get the updated version of the coding, decoding, how to work from with human, and then learn from human, and then work vice versa, and make a collaborative workplace for the productive manufacturing environment. So, when we had this initial plan in our mind to go through the knowledge transfer between human and robot, we thought, why not we check the literature, like what is in literature, because as we are doing PhD, we know the industrial barriers, we know the industry's gaps, but we also need to check what is in academic gap. So then we have checked what is in academic gap, and then we are surprised that there are actually 10,000 plus papers who are talking about knowledge transfer. So knowledge transfer is not a new phenomenon; it's a very old topic. I will not say that we are the first person who just get to know about knowledge transfer, and it's very important. But yes, knowledge transfer in human robot, not only how human and robot can transfer the knowledge in terms of coding, also how they can learn from each other and connect that to business management. That phenomenon is really new, and there wasn't supporting theory, there wasn't supporting models to back up that literature. So we have started to look into 10,000 articles. Then we had some excluding, including criteria. Then you can see we had some keywords, Boolean search term. We actually only checked on Scopus because initially we thought to go through other web search also, but then when we checked the CSV file, we saw, oh, okay, so Scopus is actually covering almost, they have Google search, then they also have the web series. So they actually MDPI, so they actually cover almost all publications. So we thought we narrow down with this 10,000, and then we had so many excluding, including, and then we end up for this paper only. This is our next upcoming paper. So for this paper only, we worked on 29 article, and then we find out, like, although all those papers talk about the barriers, the necessities, but there was really lack of theoretical support in terms of the how the knowledge transfer gap can be filled up between human and robot collaboration. And to do the literature, we have used the Prisma flowchart because it has the realm of like total human robot collaboration, filtering the vast database to the home on critical studies, and that bridge the gap between the theory and the practice. And this slide is not only to showcase the methodological approach, but also to set the stage for a discussion on the evolution of the scholarly thought on this domain, like the academic thought of this domain. And each step of this review process is delineated from the initial query to the financial selection, reflecting a commitment to the empirical study and the scholarly integrity. So when we search the literature, we actually was, as I said, it was 10,000 plus articles. So we were quite puzzled, like how we can actually narrow down the whole literature. So then we thought, why not we come up with the theme? So the first level of narrowing down the literature was based on the theme, and then we categorized the theme, and then based on the theme we actually had the codes. If you look at the codes, or if you read through the code, you will see the codes are basically, in other word I will say, the barriers of human robot interaction, like when human and robot will interact with each other, what are the difficulties they can face. And also when you are actually using the theme and implementing the course, and then using it to the industry, what are the levels of barriers you can face, like it can have individual level, it can have group level, it can have also organizational level. So utilizing a matrix to break down the course of knowledge exchange, and then these slides actually illustrate the complexity of the human robot interaction, like the barriers of human robot interaction, and then drawing from the established framework in cognitive psychological information system. Like when we did the first slide, you saw that there is psychological point of view. We categorize the knowledge types, which is tactic and explicit, and their transfer mechanism. So basically, the knowledge can be transferred in different mechanism, which can be direct instruction, which can be experimental learning, which also can be a feedback loop. So there are three ways of knowledge transfer. And then this analysis lens actually reveals the insight into the challenges and opportunities of designing systems for optimal knowledge flow that emphasize the importance of interface design, context-aware processing, and adaptive learning algorithms, which is required for knowledge transfer between the human and robot collaborative workplace. So when we had the particular gap, as for one single paper, it wasn't easy for us to choose the research question because there are so many gaps. So we thought to have just one single research question to make it realistic, and also to make at the same point to focus to like we can complete at the end of this paper, we can complete with the proper aim. So we frame our inquiry, and then we articulate the research question, then we try to elaborate, and we thought to use the mixed method approach to reveal the knowledge sharing impact on the manufacturing quality, as we are from program 4 who is actually working for quality control, quality assurance. So we thought, why not we connect at some point of the quality assurance of the manufacturing process. And then the diagrammatic representation of this research design incorporate the quantitative performance metrics and qualitative insight, which will be a combined process to investigate the data. So based on the whole process, we thought to have come up with a research question like, how does the improving knowledge sharing between the human and robots can impact the manufacturing quality? And based on the question, the main objective which we have is to investigate the strategies that enhance the exchange of knowledge between human and robot, with an emphasis on trust, communication, and access their effect on manufacturing efficiency and process quality. So when it comes to sharing the knowledge between human and robot, the first thing comes to our mind. I know we all are here from engineering background, we all are working, almost everyone are working with robot and cobot. So the first thing when we think about human and robot collaborative workplace, we think about the safety, we think about the designing the workplace safety. When I was looking through the literature, and also I saw some safety related literature, and then I was surprised actually comparing the safety. The main issue when human and robot work together is the trust. So we are trying to put this into as a main priority for our research. Like when we are doing the knowledge transfer, the trust should be the main priority. How human can trust robot when they are exchanging the knowledge, and how robot also can trust human when they are exchanging the knowledge. So based on this research question and research objective, when we are thinking about the research design, we are a bit confused what type of methodology will be a better suit for this research. And then after a long discussion, we come up with action research. Action innovation management research. I really want to take a little bit time in this slide to introduce this why we have chosen this action research, because and how this can be a best suitable methodology for this particular paper, because this methodology represents through a detailed flowchart which approach to action research. So we will explore the knows feature of action innovation management research methodology, which stands as a cornerstone of our approach to blend the theoretical exploration with practical application in the dynamic field of human robot collaboration. So we are not only considering the theoretical implementation, we are also considering the practical implementation that will also lead us to go for the mixed methodology. So this methodological framework is the creatively structured around a series of cycle. So each cycle will compromise into four phases: observe, plan, act, and reflect. So initial phase, we will have the observation phase, where the grounds of our research is the empirical reality through the extensive data collection via the field studies, survey, and stakeholder interview. So we have already completed the survey and the field studies. So a stakeholder interview, we are in process of the ethics approval. Once it's done, we will go ahead with the stakeholder interview. And then we will aim to capture the holistic view of the current collaborative practice and the challenges, because now the challenges we have in our hand, that's based on the literature. So we want to see what are the challenges is there in the industry when actually in real case or real time human and robot is transferring their knowledge. And then from there, processing to the plan phase, we leverage this insight, integrating them with the literature to pinpoint the innovation opportunity, thereby shaping our strategic innovations. And then in the act phase, these plans will come out to the futuristic when we have targeted innovations, and then ranging from new communications protocol to adaptive learning algorithms, which will be implemented, tested, and refined in the real world setting. And then we will be having all those practical implementations, and then this methodology does enclose our dedication to foregoing a symbolic relationship between our academic literature and practical utility, underscoring our pursuit to harmonizing the human ingenuity with robotic efficiency in a way that advances both industry standard and scientific understanding, positioning our research as a forefront of innovation in human and robot collaboration. So now, how we are gonna do that in real case scenario? We like how we are gonna plan for that. So we have already planned for the analysis and framing. So if you look at the analysis and framing, we have already identified based on the academic gap, like what is actually our main research gap. And then we are as we are going for the action research, so the main motivation for our research will be what is the key practical issue that this research outcome will help to solve. So it's not going to be just we will have the research question, and then we will have research objective. At the end of the research, we will just fulfill the objective. The main objective of the research will be to solve the problem which we are having initially, which is the barrier of the knowledge transfer. So, to have a deep dive into this analysis, we have actually break it through into different levels of the key analysis area. So, we have the analysis and framing, project planning, execution on the action, then reflection and learning, and then the communication at the last stage. So, if you look at this, in every stage of the explanation, we have actually included the stakeholders, because action research is very much practical research, which is not only which is not I will say much dedicated to academic only. It's more based on the industry necessities. So we have understand the problem based on the literature. So the next course of action to go and check with the industry what problem we have found out in the literature, is that a real time problem in industry or not. And then from there we will again frame the analysis, and then we will do the project planning. We will involve the stakeholders in our project planning, and then we will have the execution on the action. And then from there we will see what we have actually learned from the whole process, and then there will be a continuous communication process. So this analysis have a detailed through comprehensive Venn diagram, which actually describe the merging of academic inquiry, which we have done through literature, and also the practical challenges. So, by identifying the overlap between the theoretical gap and the industrial needs, we underscore the potential for impactful research that advances both knowledge and the application in the manufacturing industry. So, this examination of the research landscape reveals the critical insight into the barriers and the enablers of effective knowledge transfer, laying the groundwork for targeted intervention and the bridge, the divine between the theory and the practice world. So this is the few straight line between the AR research. When we are doing the action research, that is quite different from the traditional research. So we have done our first level of research question. So then we will do the data collection with the potential industry partner. Then we will get the true findings, and then we will come back, and then we will develop the research question again if it's necessary. And then we will again work on the theories, and then we will come up with the proper theory, which will be really helpful for the this particular research topic. And then based on this, actually we had in our mind like how we can actually work on this as a like what type of flow chart we can provide to the industry once we have the proper barriers, and like how they can really connect human and robot when they are doing the knowledge transfer. So this is some part of diagram is the motivation from the work later on once we have the proper data. So focusing on this, actually this is the art of knowledge and transfer. So this slide introduce the advanced concept of the technology between human and robot, and we delve into the latest advancement of AI and machine learning that enables the robot to interpret the human instruction more accurately and adapt the human behaviors and learn from the human actions, human signals, human instructions. So, visual aids that flow of the information emphasize the role of natural language processing, computer vision, or sensor technologies. So this detailed analysis illustrates the stage of the art techniques and the tools that will enhance the richness of the interactions, which will anchor the technology's advancement and drive through the next process. And then here this is, as I said, this will be the vice versa learning process. So it's not only human will be learning from robot, or robot will be learning from human. So both will have the chance to learn from each other, and then it will be connecting to the manufacturing process, so that the main manufacturing process can be facilitated or benefited from these learning benefits. So, just to give an idea, like, okay, we understand how the knowledge transfer between human and robot can be effective for the manufacturing, but how actually in real time that works. So, this is from few literature we took. This is for the assembly process. Human and robot have worked together and they collaborated between each other and they transferred the knowledge. So here at the core of the effectiveness, the coordination lies between the development and implementation of the advanced sensing technologies. They use the algorithm that enables the robot to interpret the human actions and the verbal commands in real time. Thereby, they forecast the collaborative environment. So basically, here human is giving the instruction, and then the robot is taking the instruction and doing the next level of work. Vice versa, they are helping each other, learning from the each other demonstration, and then they are helping in the quality assurance system. So we can actually have the same process based on the industry need, so we can develop our framework based on the industry requirements. So additionally, when we like especially the holistic approach, so when the version of the future workplace where human and robot collaboration is underpinned by trust, mutual respect, and technological innovation, a new era of industrial effectiveness and creativity characterized by harmonious human robot partnerships that leverage the distinctive capabilities of both to achieve the shared objectives. So, the main purpose of having this sharing knowledge is to have the shared benefits and then have the optimal dynamic in to the new heights. So the manufacturing industry can be benefited from the sharing knowledge. And then, as I said, this research is actually very early stage of research. We just did the early stage of data collection. So we will not say that the findings we had is very it's 100% accurate, but yes, the key findings from this analysis was like the effective knowledge sharing between the human and robot significantly can boost the industrial productivity, and but there should be a clear communication between human and robot, and the trust between both of them should be there. And the technological advancement in machine learning and AI can enhance the human robot management process, which will reduce the bias and improve the decision making. Because when we do the human robot collaboration or human robot integration, we actually forget about thinking how we can actually connect this with the management process. So but that's also important factor to consider, because it will help to reduce them the bias of all sort of different opinions. And as a next step of this research, we are going for the data collection. Once the ethics is approved, we will be collecting the data in real time, and then we will develop the research question and come up with the real framework, which will be helping to sort the barriers and also to help the knowledge transfer between human and robot. So stay informed and adaptable to technological advancement in robotics and AI. Thank you.
Thanks, Munia. Great presentation.
Thank you.
Has anyone got any questions? You can say a little bit more about the framework that you're planning to develop.
So basically, the framework initially we thought so one side of the framework will be human, as I showed in my little diagram, and the other side of the framework will be robot or cobot. It can be robot as well. And then in the middle of the framework will be the manufacturing process. So we initially we thought to focus only on the quality control, like we will be checking the quality, and then we thought to make it generalized so we get more potential partners to implement this framework. So the example I give you to assemble the screw, where the human is learning from the robot and robot is also learning from human. So the framework is actually something we are planning to develop, like same like manufacturing process. Also, let's say something robot is doing something packaging, and then human is also watching the packaging or helping them to do some part of the packaging. So what human is learning from that demonstration, and then how a robot also can learn from human, like how both can learn from each other and have the mutual trust on each other, and then they can develop the collaborative workplace.
Thank you.
Maybe a question. So your representation, is that going to be something that's like automatically learned, or are you going to be kind of defining that based on like your understanding of the data that comes through?
This is we are going to determine based on the data we get in the industry. So this is just the initial plan. So we will decide the middle part. We haven't fixed like how we are going to organize unless we have the proper industry partner. We know that what is their nature of production, what they are actually making, and then what part of the manufacturing we are going to look into, and then we will develop the middle of the manufacturing part, and then we will see how we can connect the knowledge transfer between this from this environment.
Right. I think Timothy has a question.
So I guess my question's more about the direction of knowledge transfer. I was a little bit unclear on which direction that was heading. Is the expectation that you'll be able to take an automated process and be able to quantify the knowledge transfer from a already scripted process that a robot is doing, or is it the other way around only, where you want the human process to influence and knowledge transfer to the industrial application?
This is more like human. We will be trying to prioritizing collaborative robots. So it's more like how a robot can learn faster from human expertise. So it will be more likely to learning. Robot will be learning from human. So from the environment or demonstration, how a robot or cobot can learn from human.
So in this case, the application is very closely coupled with what you're actually going to be able to transfer, right?
Yes.
Yeah. And you've got some industry partners already identified for that?
Yes, we have someone already identified for that, but it's still not confirmed. We are in discussion with that because we initially thought to do for quality, but then we thought just to go ahead with the normal manufacturing process to make it more generalized version of it. So we are still in discussion, and this will be, we are planning to complete this paper by Q4. So yes, I think before that we will be collecting the data and finalizing this paper.
Yep, thanks.
Well, thank you so much, Munia, for that presentation. That was really interesting.
Thank you, everyone.